So let's look at the laws relating to limiting friction. So limiting friction comes into play when we have an object placed on a surface and we apply force, and you get to go to a particular value. To that particular value of force, the object will not move. Post that, it will start moving. That is your limiting friction. For this particular scenario, rubber on rubber, the limiting friction is around 98. Okay, you can look at this graph, it's around 98. Now, we are looking at few of the facts, observations regarding your limiting friction. So basic idea is this law talks about factors that influence the object before it begins to move. Now, direction. What is the direction? What do you guys think it will be the direction? Direction of the limiting friction, what is it? Clearly to the left. Okay. So in this case, sorry, no, I should not tell left. Opposite to the direction of the force that is being applied to the object. The net force is to the right, so the limiting friction will be to the left. So it is always opposite to the direction in which the body tends to move. It's not yet moving, remember, it tends to move. Tangential action. Limiting friction is always acts tangential to the surface in contact. So let me explain it this way. This is one possibility. What if we have it tilted? Then we have the object over here. So the limiting friction will be, in this case, say we are trying to pull it up, or say we are trying to pull it down. Gravity is trying to pull it down. So the limiting friction will be in this direction. Provided it's trying to slide down. This is your direction of movement. Actually, we are pulling it down. Yeah, it's because of gravity. So it's always tangential. So here it was parallel to the horizontal. Here it's not parallel to the horizontal. It's tangential. Tangent. Remember tangent? Oh yeah, you guys are in 11th and 12th. It depends on the nature. Quite simple. So here if I change the nature, right? This is rubber on rubber. So we went to a value of 100 and all that. Now I'll change from rubber on rubber to ice on ice. So a small force itself. And the limiting friction is just around 2, 3. So it depends on the surfaces, combination of surfaces. So it just need not be ice and ice. You can go with, say, I'm keeping a steel on ice. And this is also small. Okay, so this is also small. So we are looking at dependency of nature of force. The magnitude of limiting friction depends on the nature of the surface in contact. Right? That's basically, it's there in friction itself. It's independent of the area. Fixed mass. So this is one experiment which I have not done. We should be doing that. It's generally done in your labs. The magnitude of limiting friction is independent of the area of contact because between the two surfaces, as long as the normal reaction remains constant. So let me explain this way. So this is to do with tangent, and next point has to do with area. See guys, it's quite simple. If I have an object, if I keep it like this, if I have the same object, if I keep it like this, the surface contact, in this case, actually I want to do this. I want to make a small table kind of thing. So I'm writing it here. The surface contact here is small, but here it's large. What about the normal force? Remember, normal force has to do with your pushback from the surface. If it's X Newton, this will be X Newton. So they will be same. What is the area of contact or surface contact? That's what I meant. Area of contact. So what happens is, because the surface is less here, the pressure will be more over here, it will be less over here. Okay. So the end of it, the amount of interlocking, the how hard these two are interlocked, overall will remain the same. Here the interlocking will be very hard. It will be very interlocked. But the space is less. Here the interlocking will be less, but the space is more. So the amount of interlocking will remain the same. So amount of interlocking. Again, don't complicate it. Just keep it simple. It'll be large, but the area is same. It's large, but area is same. Here the amount of interlocking is small, but sorry, not same. Area is small, that's what I meant. Area is large. This is amount of interlocking per unit area. So as a result, what happens? We are looking at this case, right? So as a result, what we have is the area will not come into play. When it comes to your friction over here, the area will not come into play, because given the same object, however you keep it, the amount of pressure will vary, and so the interlocking will change in both the cases, but overall the effect will be the same. The effect will be the same. If the interlocking is less, the area is smaller. If the interlocking is smaller per unit area, but the area is larger. So either way, the compensation, the compensation happens. The scenario will compensate the interlocking thingy, and you have the same force, same interlocking. Now, all of this is directly proportional to normal reaction. The magnitude of limiting friction is directly proportional to the normal reaction between the two surfaces in contact, that we have already seen. How hard you press to the surface, depending on that, the friction will play a role. That's common sense. Okay, if you want to take a chalk and write it on a board, right? So if you want it to stay for, become thicker, or see to that it stays, what do we do? We put pressure. We put a lot of pressure, and then we write, so that it stays for, or it sticks better. So when I put a lot of force, what happens? Yes, the chalk will, the frictional force will increase, and so then when we write it, it will stick. Okay, so this will increase the frictional force. So basically, heavier things are tough to slide than the lighter ones. So mathematically, what we have here is f of x max, that is the maximum static friction, will be equal to mu Sn, where n is your normal reaction. Mu s is the coefficient of limiting friction, and mu S max is the limiting friction. So this is a relation. So once you use it, you'll get familiar with all of this. So yeah, those are all the laws related to limiting friction. If you guys are interested, you can draw